So we have officially begun the lesson, which means if you talk out of turn, you will lose HP. Everyone is on the edge. That is in, what is it, team number 2, Los Macacos are fine. 1-15, area of circles, quiet raise hand with your card that was passed out. I think Monse's hand was up first.
Find the area of a circle.
There it is. And by a fist of 5, how well can you find the area of a circle before you even do this lesson? If you're a 5 out of 5, you've done this before, I've mastered it. Maybe you've only seen it, you kind of know what's going on, a 1 or 2 or 3. How well are... There's a 5 for Gunner? Oh, I'm surprised. Monse's at a 3.5? That's pretty good. All right, so you guys have seen this before, which make this lesson nice and easy. So let's start with some vocab. I have our 2 terms here and words, and then we're going to label this circle down here. So radius. It's a line segment that goes from the what of the circle to the edge of the circle. Is the teacher error? Where's the teacher error? I didn't say what? Oh, that's not an error, but I mean it is an error, not the XP worthy one. Today's date is in fact September 30th, 9:30. 2019. Tomorrow will be our first day of October.
It's 2020.
It is 2019, not 2020. So radius. Anyone want to give me a quiet raise hand? It goes from where to the edge of the circle, if it's a radius. Jose? It is the center. Thank you. And thank you, Game Warden, for giving Jose his 50 XP, which means if I come down here and label this on my circle, here is the radius. And we can label this thing is called the radius. So think of it as kind of like half the length of the circle. And then the diameter, it's a line segment from the edge of the circle to another edge of the circle. But it also has to pass through something, because if I just go from one edge to the next edge and do a line right here, that's not the diameter. What does it need to go through in order to be the diameter? Andres? Again, the center of the circle. There it is. Thank you, Andres. It's going to be another 50 XP. Thank you, Game Warden. So let's do this in a different color. Let's do it in black. So if I go through here, that is called the diameter. I'll do that in black here. That is called the diameter. And I mean, that's good enough for this lesson, but I might as well just kind of front load the vocab now. So we'll do vocab that will be used for the rest of the unit whenever we get to circles. You don't need to know these, but if I go from a point on the circle to another point on the circle that doesn't go through the center, that thing is called a chord. Like a cord of wood. C-H-O-R-D. C-H-O-R-D. What are some other things that you know? Ooh, from Yosemite we know a few other terms, so let's do another one. Let's do this one in red. If I go through the circle, let's actually move this like that, so it goes through that point. If I go through that one point, if I only touch once, does anyone remember what this is called for 50 XP? If it touches once, who knows this? Maybe someone held on to their notes? Gunner? No. Andres?
Tangent.
It is indeed the tangent. Write it down. Tangent. Tangent only touches at one point, and then if I have a line that touches through 2 points, so let's do, I'm running out of colors here, let's do green.
Is it XP, Mr. Smith?
If I go like this, it is another thing of XP if you know this one. Does anyone know what happens if it's not a tangent, not 1 point, but it touches at 2 points? Here and here. Anyone know this name? No?
What did it start with?
S? Say it louder, Sergio.
Oh, segment?
Oh, close. It is a line segment if it ends right here and here. But if it's just a line, it's called this. Oh, yeah, Jose. Good guess. Supplementary is whenever they add up to 180 degrees. This one is called a secant. A secant line. A secant line touches twice. Tangent line touches once. If you guys ever take AP Calculus in a few years, then these words tangent and secant are going to be used over and over and over again. Any other things that we need to know? That's good for now. Let's go down here to example number 1. What is the radius and the diameter of the following circle? So let's go ahead and write down, let's say R is equal to blank and D is equal to blank. Who knows these? It's labeled right there. You just need to know which one is the radius, which one is the diameter. You need to have units on this one. Quiet raised hand. I'm looking for a participation card, if possible. Fernando, give us one of them.
The radius is 3.5.
3.4
4, I mean.
centimeters. There it is. Thank you. So Fernando is in. And I need another quiet raised hand. What is the diameter then? Cohen?
6.8 centimeters.
There it is. 6.8 centimeters. Everyone write it down. Cohen, how'd you get 6.8? Can you tell us the process? There it is. All right. Gunner Hood. Andres, your laptop should be shut. All right, we're on to area. Andres, thank you. So area. How many of you know the formula for area with a quiet raised hand? No? I was expecting maybe 2 people with the scores that we got at the beginning. No? Okay, so here it is. Area. And this is something you'll know by heart for the rest of your high school career, and maybe if you go to college as well. Pi r squared. And I'm hoping someone asks, maybe not out loud, but definitely in the back of your mind, why? Why is area equal to pi r squared? And unfortunately, I can't give you a proof until you hit calculus, but I can give you an informal proof once we talk about circumference. So once we get to the back of this page and I give you the formula for circumference, we'll come back and revisit why the area of a circle is pi r squared. It's kind of a fun question. Let's go to example 2, though. Let's use, hold on, before I jump to example 2, what is pi? Let's talk about pi for a sec. Can anyone give me just anything that you know about pi? Julian, with your card, yes. Say again?
Numbers.
Numbers, plural or number singular?
Numbers.
What do you mean by numbers?
A lot.
It's 7, it's also 9, it's also,
Infinity amount.
it's an infinity amount of numbers.
Yeah.
In terms of after the decimal, I'll give it to, yeah, sure. We'll give him 50 XP, I'll take your card. Is that Jessica's card I see? Yeah, go for it, Jessica.
Wait,
Do you know what
is
it's?
pi 3.14?
Its approximation is indeed 3.14. We can all write it down. It's about 3.14. But it does go on and on forever, as Julian said. It has an infinite number of numbers after the decimal place. It goes on and on. If you want to know the word for that, it's called transcendental. I'm not going to be able to spell this. Transcendental? I think I got it. Transcendental means it goes on forever and ever, and it never repeats. Like, if I do 0.11111, that's technically not transcendental. It just means it goes on forever. Transcendental means it never repeats. There's no pattern to it. I can't list all the digits. 0.111 repeating, by the way, is 1/9. Anything else about pi? Andres?
It's a decimal and 3.1592
3.14.
3.14159.
Yeah, those are more numbers. Do you guys want some more numbers? Even more than Andres? Are you ready?
There's a 69.
3.14159265358979 323834626433832795028841971. There's a lot of digits that I know. I got up to 70 at one point. I could probably easily get 40 now.
How many digits are there in pi? How many particles?
It never ends. It's
It's
infinity.
infinite.
Yes.
It's an infinite amount. Of
That means if someone tells you they know the last number of pi, they are lying. Because there is no. Okay, the memes. All right, so let's come down here to example number 2. What is the area? And I want you guys to leave pi in your answers. When you go to Khan Academy, if you type in the letters P-I, it immediately turns into just pi. This turns into the symbol pi, and you'll get it exactly correct. And if I go on my laptop and I do Spotlight search, command space, and I type in Pi times 1, it'll give me 3.14159265535, and it rounds because the next number is 8, so it rounded this to a 6. But you can do pi times 5, and you can get an approximation of where that is, which sometimes Khan Academy will let you. They'll say, maybe use 3.14 for pi. 3.14, and I can say pi times 5 is about 15.7, but we should all know if I do pi times anything, it will go on and forever and ever. So, I want an exact answer and I want a rounded answer, but you guys all, I want you to be using exact answers for Khan Academy. It makes your lives so much easier. There's less multiplication. So, I gave you the diameter. Notice that there is an r in here, which means I need to somehow convert the diameter to a radius and then plug it into my formula. So, is there a quiet raised hand that can give me the area of this circle? Sergio, you have your card in. You've turned in your card like 7 times now. Andres, give me your card.
That's -8.
Your card has been turned in already.
Two more.
Gunner, you had your card turned in too, didn't you?
Not.
No? Okay, I'll take it now. Gunner, tell us the area of the circle. The area is not 3.
Wait. Oh wait.
The radius, however,
Oh, the radius is 3.
the radius is 3. Everyone write it down. If d is equal to 6, then this length right here, r, is equal to 3. The radius is 3. And because Gunner got 3, Gunner, you may now plug that into the formula, and we get area. A is equal to, just follow the formula, tell me what to plug in. Pi.
R.
Well, what is r?
3.
3, we'll put it in parentheses.
Squared.
Square it. Go ahead and simplify, Gunner. What's 3 squared?
3 squared.
3 times 3? There it is. So our final answer is 9 pi. And we'll say 9 pi units squared. Units squared. And there it is. It's that easy. You plug it in. What if you actually wanted to figure out, well, how much square footage am I getting there? Like if you tell a farmer, you'll have about 1,000 pi units or feet squared, they'll be like, is that a lot? Like how big is pi? How much area and crops am I getting here? He wants an estimation. So we can estimate and we can say the area is approximately, you can do a little squiggly equal sign, and I pronounce this thing approximately. Because whenever I round, use squiggly equal sign. Use approximately. The area is approximately, and this is where you have to pull up your calculator. You could do a few things. The easiest thing is just to say, well, pi is about 3.14. So I can say 3.14 times 9. And it's about 28.26. So again, to get approximately, multiply 3.14 by whatever the number is. Change pi to 3.14. But it is no longer exact. We have now approximated. So 28.26, 28.26 units squared. We approximated by making pi, and we'll make a note here. This approximation right here assumes pi is approximately 3.14. But on Khan Academy, you're just going to type in 9 pi and it'll change to pi and you'll be done. It'll be that easy. No multiplication required. That is the best way to leave your answers because it is exact. Although in layman's terms, maybe the farmer won't understand you, but in terms of math, it is very precise. When we're talking about math practice number 6, attend to precision. All right, you guys think you can get this if I give you another one? We'll try it after we talk about circumference. I'll let you do example 3 by yourself. Question, Sergio.
Who cleaned the fish tank?
I don't know. I assume it was Miss Heather, but someone got access to the magnet that Jaden bought and cleaned the fish tank.
I did it and do I get XP for cleaning?
I mean, if you did it, then yes. Let's talk about circumference, and then I have a whole lesson on circumference, so I'm just going to give you the formula for now, and we'll talk about it more in depth at a later date. But circumference. Quiet raised hand. Who knows the formula for this? Review from, I don't know, from forever ago. No one knows it. Andres, you want to take a guess? It has a pi in it somewhere. Pi times.
R squared.
You're close. So there are 2 things that you can write here. You can write 2 times radius times pi, or what is 2 times the radius? Quiet raised hand. What is 2 times the radius? Cohen said it earlier. What is twice of the radius?
The answer.
What is... Monse,
R
I said
squared?
quiet raised hand. Monse.
Do people die now?
No, she's in the other group. She's safe.
Oh, let's go. Not good.
Quiet raised hand. Monse, go for it. It is the diameter. So this 2r right here is really the diameter, so I can say that this is really diameter times pi if you want. But normally, over and over again, I'm going to write 2 pi r or 2r pi, whatever you want to say. It's going to be twice the radius and then multiplied by pi.
What's the radius?
Multiplied by pi. And then circumference again. The way to think about circumference is if I am an ant, if I'm something really tiny, maybe I'm Ant-Man if we're in the Marvel universe, and I'm walking around the circle. If I start right here and walk around the circle, the distance that the ant has walked by the time they get back to the same point is the circumference. The circumference is the length of the circle. As if I got an axe, I chopped it open right here, and I pulled it all apart. The length of that circle would be the circumference. So, this is the point where you guys get to sit back, relax, and watch a video. As long as you're paying attention, then this will go smoothly. Let's go watch our video. And I need to turn my cool lo-fi hip-hop radio off. That's on.
Wait, isn't it pronounced Lofi?
It's lo-fi. Shh, shh, shh. Guys, shh.
But where does pi r squared come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So, if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So, how small must we divide a circle before we can get a perfect rectangle?
That one.
Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle.
Wow. So cool.
So, the area of the circle is equal to the area of the rectangle, which is equal to base times height. The height of the rectangle, as you can see, is the same as the radius. So height is equal to radius. To find the base, we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r. When we combine it with 1/2, the 2's cancel out, and the base is equal to pi r. So now, base times height becomes pi r times r. Combine the r's together, and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle. So,
The end. It's an informal proof because his wishy-washy way of saying, we'll just keep dividing the circle into smaller and smaller parts. You need to be a little bit more formal about it, but you have the gist of it. You have to take the limit as the number of segments goes to infinity.
10 seconds left. I want to see what are you hiding? What are you hiding?
I mean, you guys are going to have to go look it up on your own.
I don't want to look that up. I'm going to do things that
So hopefully you now believe me. I'm not just some prophet up here telling you it's always pi r squared and you don't need to know why. That's a general idea of why it's pi r
What
squared.
if you did that video?
What if you made that?
If I made that video, it would be a little bit better.
Wait, what if your brother did
Miguel,
that
what are you
video?
saying?
So we're going to go to example 3. You guys are all doing example 4 on your own. So make sure you understand example 3. It's the hardest type of question I can ask on a quiz or on a test. So I'm giving you the circumference. I'm saying that the length of the circle all the way around is 37.7 about, because I'm rounding here. It actually had a pi in it. So it's about 37.7 units. I want to know what the area is. So we need to set up 2 different formulas here. First, we're going to start with our circumference. So everyone write it down. We know that circumference starts with, I'm going to say 2 pi r in this case. 2 pi r. I'm just switching the r and the pi. It's fine to do that. It's the multiplicative property of communication. or the commutative property, I don't know why I say communication, the commutative property of multiplication. So 2 pi r. Is anyone lost? If you're lost, you need to ask a question.
So
This is the time where you can shout out. If it's
So-
proper, if it's not a good question, then we're going to lose HP.
Did you Oh wait, do I have to raise my hand?
You can shout it out for now.
Okay. Did you have to put that formula because you have to find
I'm just copying down from
the
this.
circumference or?
It gave us the fact that we had circumference, so I'm copying down the formula for circumference. It told us that C, this C right here, the circumference is 37.7. So my next line is going to say, well, that left-hand side is really 37.7. And I guess I can put parentheses if I'm being really careful, is equal to 2 pi r. All I've done is I've changed the fact that circumference is 37.7. I'm going through this very slow. Of course, there are shortcuts. Of course, I could have just immediately written 37.7 equals 2 pi r. Well, now I need to solve for the radius. Look what happens here. If I solve for the radius, and I get radius by itself, and I know the number for radius, I can plug it back in to my formula for area. And then I'm done. So the goal here is getting the radius by itself. So I need to isolate r. Quiet raised hand now. How do I isolate r? What do I have to do to both sides of the equal sign to get rid of this 2 pi? Fernando.
2 pi divided by both sides.
Yep, there it is. Divide both sides by 2 pi. So the right side divide by 2 pi, the left side divide by 2 pi. And theoretically, well, not theoretically, what happens, the 2 and the pi are gone. We have isolated r. So we know that r is equal to 37.7 divided by 2 pi. Well, let's see what that is. If I come up here and, again, because we approximated, you can use 3.14, or you can just use pi, whatever you want to use. So if we approximate it, I'm going to say 37.7. I'm pulling up my calculator here. You can use Spotlight Search, or you can use Desmos calculator as well. 37.7. And if I divide that by, in parentheses here, 2 times, I can say pi, or I can do 2 times 3.14. It doesn't matter. We get very, very close to what number? Quiet raised hand. Easy peasy XP here. There's only 2 people that know how to read. Cohen. It's 50 XP for Cohen. It's 6. So the radius is about 6. So now we can make an approximation here. We can say the radius is approximately 6. Make that 6 slightly better. Again, that step can be confusing, so I will do it again. In fact, I'll use a different method now. If I come over here to my calculator, so I'm going to do 37.7 divided by 2 pi. 37.7 divided by 2. If I type in pi, it turns into 2 pi, and there it is. It's about 6. And I can zoom in too. I'm sorry that you guys couldn't see that. It's about 6. So far, so good? All right, so I'm going to come back. So I know my radius. What's my next step? Regurgitate it back to me. What am I trying to do here? What is the whole goal? What is the question asking from me? And then tell me how to do it. Oh God, the same 2 people over and over. It's always Fern and Andres. Sergio Hood. What's the next step? Come on, guys, you got this. Someone aside from Fernando and Andres. Oh, it's a question, Andres? What's
So
up?
why is there a green box?
Why is there a green box?
Yeah.
That's my recording area.
Oh.
Sergio, go for it.
6.
Yeah, plug in 6. Tell me what the original formula is, and then we'll plug in on the next line. What's the original formula?
Pi.
Area is equal to pi r squared. And then when I plug in, I'll get area is equal to pi 6 squared. Let me make this slightly neater. 6 squared. And then Sergio, I'm not done with you yet. What is 6 squared?
36.
There it is. So area is equal to 36 pi. And if I was being, since we had units here, just square it, and it's units squared now. Units squared. And sometimes Khan Academy asks you to approximate that. If you need to approximate, what should I substitute out for pi? Quiet raised hand. If I want to approximate, pi turns into what number? We've said it like 3 times already, Cohen. It is indeed 3.14. So using pi is approximately 3.14. We can say that the area is approximately, I come back up here to my calculator, I need to do 36 times pi. are 36 times 3.14. So if I come back over here and I say, zoom out a little bit, if I say 36 times 3.14, I get 113.04. How close is that, I wonder? So if I do 36 times pi, it's really, really close. It's off by 0.057. So 113.04, that's the number I'm looking for. 113.04. 113.04 is another approximation. Again, we have a little squiggly equal to say it's approximately that units squared if we needed to approximate. So we have those two answers. We have, and I guess this one can't be exact since we approximated all the way back here, but it's still closer than this one is. All right, so you guys should now be able to do example number 4 based off of example number 3. Are there any questions on example 3 before you begin example 4 on your own? Question, Jose. You may use a calculator. Use Desmos on your laptop. You may not use your phones. If you have your phones in my class, that's a bad thing, and I'm going to find them and take them away. Other questions? All right, good luck.